Good morning everyone. Myself Pratimay Sahu. I am the lecturer of Electronics and Telecommunication Engineering. So in previous video, I have already discussed about the microprocessor, then the general boss of microprocessor, then what is microcomputer. Okay. So today I will discuss about architecture of 8085 microprocessor. So the block diagram or the architecture of 8085 microprocessor consists of 6 major blocks. So first one is ALU, that is Arithmetic and Logic Unit. Second one is Register Array. Third one is Timing or Control Unit. Fourth one is Interrupt Control Unit. Fifth one is Serial Input Output Control Unit. And sixth one is Instruction Register and Instruction Decoder. So first of all, we will discuss about ALU, that is the first major block of 8085 microprocessor. So ALU stands for Arithmetic and Logic Unit. It consists of accumulator, temporary register and flag flip-flop. So it performs arithmetic and logical operations like addition, subtraction, multiplication, division on 8-bit data. So during operating, the first operand must be stored in accumulator and the second operand comes from temporary register, which is present in either memory or any one of the general purpose register. So by doing the operation means arithmetic and logical operation, so two data means we have to require two data. One data or first operand must be stored in accumulator and the second data or operand may come from any temporary register which is present in either memory or any type of general purpose register. Now the content of accumulator and temporary register are input to the ALU. So after arithmetic and logical operation, the result is also stored in accumulator. So according to the result, the status of the flag and flip-flop will be changed. So this is ALU. Next come to register array. So this is the diagram of register array. So here one accumulator, that is 8-bit register, is present. Then B, C, D, E, H, L, these 6 type of general purpose register are present. Then stack pointer, so it is also one 16-bit register, and program counter, it is also one 16-bit register. So two 16-bit registers are present, that is stack pointer and program counter. So there are various types of registers in 8085. These registers are used for storage, manipulating data and instructions. The different types of registers are accumulator, temporary register, general purpose register, program counter, stack pointer, instruction register and flag register. So it has 8 addressable 8-bit registers, that is A, B, C, D, E, H, L and F, and two 16-bit registers PC and SP, that is program counter and stack pointer. These registers can be classified as general purpose registers, temporary registers, that is W and Z registers, special purpose registers, that is accumulator, flag registers and instruction register. So first of all, we have discussed about what is accumulator. So it is a 8-bit register which is used to perform arithmetical and logical operation. It stores the output of any operation. It also works as registers for input-output accesses. Then temporary register. It is a 8-bit register which is used to hold the data on which the accumulator is computing operation. It is also called as the operand register because it provides the operands to ALU. So the ALU has two inputs. One input is supplied by the accumulator and the other from the temporary data register. The programmer cannot access this temporary data register. However, it is internally used for execution of most of the arithmetic and logical instructions. So, W and Z registers are temporary registers. These registers are used to hold 8-bit data during the execution of some instructions. Then come to general purpose registers. So, microprocessor consists of 6 general purpose registers of 8 bits each, named as B, C, D, E, H and L. So generally 3 registers are not used for storing the data permanently. It carries the 8-bit data. So these are used only during the execution of the instruction. So these registers can also be used to carry the 16-bit data by making the pair of 2 registers. The valid register pairs available are BC, DE and HL. So B is paired with C, D is paired with E and H is paired with L during the execution of 16-bit data only. We cannot use other pairs except BC, DE and HL. So these registers are programmed by user. So all these general purpose registers are 8 bits wide. So they are less important than the accumulator. They are used to store the data temporarily during the execution of the program. For example, there is no instruction to add the contents of B and E register. At least one of the operand has to be in accumulator A. Thus, to add B and E register and to store the result in B register, the following have to be done. That means it is possible to use these registers as pair. So, BC, DE and HL are used for 16 bits operation. Then next come to program counter. So it is a 16-bit register used as memory pointer. It stores the memory address of the next instruction to be executed. So we can say that this register is used to sequencing the program. Generally, the memory have 16-bit addresses so that it has 16-bit memory. The program counter is set to 00H. Then stack pointer. It is also a 16-bit register used as memory pointer. It points to the memory location called stack. Generally, stack is a reserved portion of memory where information can be stored or taken back together. So in stack, the data are entered in a LIFO manner, that is last in first out. Then next is instruction register. So it is a 8-bit register. When opcode of an instruction is fetched from memory, then it is stored in this register. This is not programmable and is not available to the programmer. Next is flag register. It contains 5 single-bit flags and 3 unused bits, which changes its status according to the result stored in an accumulator. So, it is a 3-bit register in which 5 of the bits carry significant information in the form of flag, that is sign flag, zero flag, auxiliary carry flag, parity flag and carry flag. And the 3 bits are unused, that are not used. Next, come to timing and control unit. So this unit of microprocessor issues necessary timing and control signals for the execution of instruction. It generates 3 types of signals, namely status, control and timing signals required for the operation of memory and I/O devices, that is input-output devices. So this unit, with the help of these signals, controls the entire operation of the microprocessor and the peripherals. So the signals associated with this unit are two control signals and three status input output S1 and S0 to identify the nature of the operation, and one specified signal ALE, that is address latch enabled, which indicates the starting of the operation. So this is the main control unit of the microprocessor, which controls the entire microprocessor system, that is timing and control unit. Next is interrupt and control unit. So when microprocessor receives any interrupt signal from peripherals which are requesting its services, it stops its current execution and program control. Is transferred to a subroutine by generating call signal, and after executing subroutine by generating RET, means return signal, again program control is transferred to main program from where it had stopped. So when microprocessor receives interrupt signals, it sends an acknowledgement INTA to the peripheral which is requesting for its service. So when microprocessors receive interrupt signals through pins or hardware of microprocessor, they are known as hardware interrupts. There are 5 hardware interrupts in 8085 microprocessor. They are INTR, RST 7.5, RST 6.5, RST 5.5 and TRAP. So that's all. Thank you.